Hi, this is Miss Yochum, and we had some questions about assignment 25 on valence electrons. So I thought I would go over it really quick in a short video. If you remember, assignment 24 was the Build an Atom Lab. And if you look at this before we move on to assignment 25, the atom is made of protons, neutrons, and electrons. I'm going to add just a few things in the nucleus here, one proton and one neutron. And then it consists of rings of electrons. The first ring can only have 2 electrons. And then look what happens if I try to add a third electron to that ring. Boop, it won't go in there. So the first inside ring can only hold 2 electrons. And then the second ring can hold up to 8 electrons. These electrons in the outer ring are called valence electrons. And as we'll learn in this activity here, if I can get these to stick, atoms want full outer rings. I don't know why that won't stick. Okay. So right now, the inside ring can hold up to 2 electrons, and then you saw it maxed out. So 2 can go in the first ring, and then up to 8 electrons can go in the second ring. So right now, this atom has 2, 3, 4, 5, 6, 7 total. And it needs 3 more electrons to have a full ring. All atoms want full outer rings. So let me throw 3 more in there, and this would be considered to be a stable atom if I add all those protons in there too. So it's got 2 in the inside ring and then 8 in the outer ring. So that is a stable atom. Let's go on over here to assignment 25, and it says to type your name here. And then this focuses on valence electrons. So on the next slide, it talks a little bit about the Bohr model. The Bohr model was developed by Niels Bohr, and it shows the electrons that are on the outside of the nucleus. And question number 1 says, how many electrons does the atom above have in its innermost ring, and how many does it have in its outer ring? So if you count the inner ring, it has 2. That's the maximum that the inner can have. And then in the outer ring, this atom has 1, 2, 3, 4, 5 electrons. So its outer ring is not full. So the Bohr model ring rules are on the next slide. The atomic number is the number of protons and electrons. Each ring can only hold a certain number of electrons, and we fill the electron rings in pairs, starting with the inside ring that can have up to 2. So this next slide shows if we were going to draw the Bohr model, this first inside ring has 2 electrons. If you look in this picture right here. The second ring can hold up to 8 electrons, so we put them in pairs. And the main reason to do that is it's easy to count, and electrons also exist in pairs. So 2, 4, 6, 8 in the second ring, and that ring is full. The third ring could also have up to 8 electrons if the atom has that many electrons. Okay, so in the next, it says to describe how many electrons can go in each ring. So we learned in the ring rule back there that the answer would be 2 in the first ring, 8 in the second ring, and 8 in the third ring. So you would type these answers there, 2, 8, and 8. All right, slide 6, valence electrons are the electrons in the outermost ring. So if you look at this picture here, this atom only has 1 valence electron, and they colored it red just to make it stand out. That's a very unstable atom. It's very highly reactive because it doesn't have a full ring. Its outside ring is very empty, and it needs 7 more electrons to fill up that ring. So it's a very unstable atom. But the question just says, how many valence electrons does the atom in the picture have? So that would be 1. This one, the answer would be 1 here. Okay, let's go to the octet rule. Atoms want 8 electrons in their outer ring to be stable. So neon is a very stable element because it has its 8 electrons in the outer ring. It's a noble gas, and that's in group 18, which is the last column on the periodic table. and it's very stable. Atoms want 8 electrons in their outer ring, and they will gain or lose electrons in order to have a full outer ring. So if we have an atom that had only 7 electrons in its outer ring, it would go try to steal an electron from another atom. It's very reactive. So that's why bonding ends up happening, because an atom will try to steal an electron from another atom to fill up its rings. So number 4, what do atoms do if their outer rings aren't full? They will gain or lose electrons to fill up their ring. How many electrons does the neon have in its outer ring? So the answer is, if we counted these up, the answer is 8. It has its octet, so it is a very stable atom. Let's see. Atoms with a full octet like neon are very stable. They have full rings. They're happy atoms. Atoms with only 1 valence electron are very unstable. So then in this question, you're to describe whether neon is stable or unstable and explain why. Okay. And last is just to summarize the activity. What is a valence electron? Remember, valence electrons, let's recall, are the outermost electrons. They are the electrons that are responsible for an element's reactivity, whether it reacts with another atom. Describe the octet rule. Octet means 8. Octagon, it has 8 sides. Octopus has 8 legs. Octet rule is that an atom wants 8 electrons in its outermost ring. And then lastly, how do valence electrons determine if an atom is stable or unstable reactive? Okay, if you'll recall, when we go back here, neon is very stable because it has its octet. An atom like this is very unstable because it only has 1 outer electron. As we'll get to learn later, atoms will do what's easiest. They want to fill up this outer ring, so they have a choice. They're not really alive, but we say they have a choice. They could steal 7 electrons to fill up this outer ring, which would be a lot of work, or they could give up this electron right here. And if I cover it up here, if I take it away, then you'll notice that this inner ring is actually full. 1, 2, 3, 4, 5, 6, 7, 8. So it's actually easier for this atom to give away its electron than it would be to steal 7 more. So that's just a little something for the future about how atoms behave. If it's easier to steal 1 or 2 electrons to fill up the ring, then that's what they'll do. If they have a pretty empty ring, then it might be easier to give away 1 or 2 electrons. If this inner ring here, then it's full. So that's just something a little in the future when we talk more about atomic behavior. So I have reviewed all of these questions here, and I hope that was helpful. If you have any further questions tomorrow, you can come during office hours, which is pretty much all day with the exception of lunch time. I will be online, and you can get in on the live conversation and ask any further questions that you have. I hope you have a good weekend, and I'll talk to you all soon. Bye.